Hey McLaughlin Superstars, it's Mr. Curtis and the 4th grade team. It is June 2020. Holy cow, I can't believe it's June. And to celebrate, we're going to do some fractions. And today's activity in 6-8 comes from Houghton Mifflin Carcourt's Math Expressions. And it's pretty much a review of what we did last week. So here are our two targets today, Superstars. First is we're going to solve problems, numerical problems that require multiplying a fraction by a whole number. This is what we started last week. And then we're also going to solve word problems, sometimes called real-world problems, that requires multiplying a fraction by a whole number. Again, these are two things that we did last week. So this will kind of look like the Google Slides for your task today. So let's go ahead and get started. Get out your paper, your pencil, and maybe a glass of water, and let's get going. So, paper, pencil ready? So what I'd like you to do first, Superstars, is I'd like you to draw a model, and then we're going to solve. So here we have 4 wholes times 4/5. What I'd like you to do is I'd like you to, on your notebook paper, I'd like you to draw 4 bars. Now, the bars should be about 2 lines tall in your notebook paper. And you're going to do 4 of them, kind of like this. And that will represent the 4, the whole. All right? So, we're going to also have you, underneath those 4 bars, would you write this equation? Now, do you remember what we do first when we multiply a whole number by a fraction? Yeah, if you said you're going to make a whole number into a fraction just by simply putting it over 1 as a denominator, great job. So let's do the math first and use the model to prove it. All right, so we can, when we're multiplying, we can just multiply across. That is so great, right? And 4 times 4 is 16. And so then our denominators, remember, they do not have to be common to multiply. And 5 times 1, of course, is 16/5. Now, I have some bars already here done. What I'd like you to do in each bar is to basically create fifths, something like this. And again, if they're not exact, that's okay, as long as you have each of those bars looking like that. Push pause if you're going to do that now. All right, I'm hoping that you already drew the 4 whole bars. Now let's go ahead and after you've drawn those, we're going to, and you've divided them into fifths, would you blacken out the last one? So you can just use your pencil and just kind of cross it out. That's what we don't have because we don't have all of them. We have 4/5. You don't have to color them in. I use yellow here as an example. But here I have 4/5 times 4 wholes. And when I count them, 4, 8/5, 9, 10, 11, 12/5, 13, 14, 15/5, and 16/5. Good, so that actually works. Now we have 16/5. Now in your model and in your notes, do you remember that we also can turn this into a mixed number by dividing? The number on top goes in the box. The number on top goes in the box. The numerator is going to be divided by the denominator. And how many times can we divide 5 into 16 without going over? 5 times 2 is 10, not quite enough. 5 times 3 is 15. Boy, that sounds good. So that whole number is going to be a 3. Remember, your quotient is your whole number. The second part of division is multiplying the divisor by the quotient. So we did 5 times 3 is 15. Now we have to subtract to see if there's going to be any leftover remainders, which is going to be your numerator. And remember, the denominator is nothing changed with the size of the fifths. So it looks like we have 3 and 1/5. Now let's go ahead and watch me here. I'm going to take these and kind of ungroup them. All right, and just to kind of prove it. So, boom, boom. Okay, and again, apologize for time here. And just for speed, I'm just going to move that there, and I'm going to move that there. Okay, and now I'm going to ungroup these just to see and prove that 3 1/5 is the same thing. All right, so now I'm going to, there's a hole, there's a second hole, right, because all fifths are filled. There's a third hole, and what do we have left over? Right, just one. So we have 3 holes and a fifth. So when we multiply 4 holes by 4 fifths, our answer is 16 fifths, but it's also 3 1/5. Now here's some actual work from, get your notebook paper ready, keep it ready, from today's activity. We did number 12 for you. So go ahead and match me, give yourself some space. Oh, and I don't want to forget, when we have word problems, we do use the units, but we don't have that quite yet. These are just numeric expressions, so we can solve these without the words or the units. Sorry. Okay, so here we go. 21 times a third. Okay, 21 times a third. So write this equation out, and do you remember what you do first? Yep, you remember that you can just simply put a whole number over a denominator of 1 to make it a fraction. Now what's 21 times 1? That's beautiful, right? That's 21. And what's 1 times 3? Yeah, it's 3. So we have 21 thirds. So 21 thirds is actually partially correct, right? So it is an answer that would be acceptable, but can we simplify that? So do you remember how we can take 21 thirds and simplify it back to a mixed or whole number? Remember here it says write your number, or excuse me, your answer as a mixed number or a whole number when possible. That means you're going to divide it to see if it's going to be a whole number or a mixed number. So the number on top goes in the box, and we divide it by the denominator. Now how many times can 3 multiply into 21 without going over? 3 times 5 is 15, 3 times 6 is 18, so it's going to be a 7. So our whole number is a 7. Now let's see if there's anything left over. So since we said 7 times 3 was 21, now this is pretty big. When you have no remainder, that means you don't have a fraction, because a fraction is a leftover. There's no more leftovers. You created 7 new wholes. That's really important that you realize that. We have 7 wholes. I saw, and some of the other teachers saw, that you may have put a fraction of 0 over 0. And that really isn't going to be an appropriate fraction, at least until you get to high school. Okay, so we don't need a fraction of 0 over 0. All right, so wait till you deal with imaginary numbers later. Okay, so now the last slide has to do with word problems. And again, number 12 is done for you on your work page. Let's go ahead and go to the real word problems or real world problems. And we decided to do number 18 together. So the instructions, again, read the instructions. Write an equation, then solve, then write your answer as a mixed number or a whole number like last time. Some of you are skipping part of it. Some of you are forgetting to write the equation. And we're going to do that now. And it's also in the Google slide. All right? So let's get to work. So first off, let's read number 18. Zara's dog Brutus weighs 7/8 of a pound when he was born. Now he weighs 60 times this much. How much does Brutus weigh? I want you to think before you write. What's the equation? Are we adding, dividing, subtracting, or multiplying? So let's start with the whole number. What is the whole number in this equation going to be? If you said 60, that's right. 60. What is the operation that we're going to do with 60? Times means multiply, right? And then what are we going to multiply the whole number 60 by? 60 times what? Good, 7/8. And again, I already included the word pounds. We're going to use that as our unit. We want that unit as part of our answer. Okay, so now we know that if you could write 60 times 7/8. Now the beauty of multiplication is you can commute them, and you could write 7/8 times 60. Either one's great. Okay, so let's go ahead and get to work. So what did you write as your equation? Well, I first off use my eraser here. 7/8 times 60. So we know that, but what do we do to 60? Yeah, it's actually 60 over 1. Right? So 60 over 1 times 7/8. That's a way to multiply a whole number. He's 60 times more than he was when he was born. So he got a lot bigger. He was really small to begin with. So we obviously need an equal sign. And what do you do first? You multiply across. Would you multiply across, please? If you remember that 6 times 7 is 42, and 6 tens means we could add a 0, it's 420 as the numerator. And 8 times 1? Yeah, it's 8. So we have 428. Now that's not simplified. Remember, write as a mixed number or a whole number. What do you do with 420 over 8? The number on top goes in the box. We're going to divide that. The number on top goes in the box. So if you already did it and you found that there's 52, but there's a remainder of 4. 52 and 4/8. There was 4 remaining and the denominator stayed the same. 52 and 4/8 is a great answer. It's right. And if you can also see that you can simplify 4/8 into a half pound, that's great. 52 and 4/8. These three answers, do you notice that they're all equal? They're all equivalent? All of those answers will be correct. But because the instructions asked us to write it as a mixed number or a whole number, this is the answer we're really looking for. And if you have simplified this, great job. But we're really looking for this answer to begin with. So we've got 2 of our problems done in your slides. We hope you have any questions that you can email us or send us messages. Watch this video, rewind, pause as you need to. We're looking forward to seeing your responses, and we're hoping that you're enjoying these activities. Happy June 1st. Bye for now.